Okay, so this is going to be the second set of slides talking about solutions in colloids. So we're going to talk a little bit about concentrations. Because solutions are mixtures, we can add different amounts of solute. We can have, and you probably understand this in a general sense. You can say, oh, this coffee is really strong, or that tea is too sweet, you put too much sugar in there. But in chemistry, of course, we need much more specific measurements of concentration in order to do calculations that are needed. So, we're going to learn about concentration, and we're going to express our concentration as the amount of solute contained in a specific amount of solution. The two different types of concentration units that we're going to look at are molarity and percent. Okay, molarity is the first unit that we're going to talk about, and it is the one that most chemists use because it has to do with moles. So, molarity is expressed as the number of moles of solute contained in 1 liter of solution. So we can write that as moles of solute divided by the volume of solution, and you want to make sure that volume is in liters. So if you look on the bottom left, you can see molarity is moles over volume in liters. You can also rearrange this equation, so if you know what your volume and your molarity are, you can find moles. Molarity times volume gives you moles. And if you want to try to find the volume, if that's your unknown, you can take moles divided by molarity. So here's an example. Let's say we have a 250 ml sample of a solution that contains 0.134 moles of solute. Calculate the molarity of this solution. Alright, so to find molarity, we need to know moles divided by liters. So we're given the moles in the problem, 0.134 moles. First, though, we need to convert our milliliters to liters. And so to convert, we divide by 1,000, or we move the decimal place over 3 places. All right, and then you can plug that in. So molarity is 0.134 moles divided by 0.250 liters, or 0.536 moles per liter, which you can also say molar, 0.536 molar. All right, in example 2, so just a slight variation, because most of the time we have to measure things by weighing in the lab, so we can't figure out moles, or we can't weigh moles. So 9.45 grams of methyl alcohol was dissolved in enough pure water to give 500 mils of solution. What is the molarity of this solution? Again, the first thing we should do is convert milliliters to liters. 500 milliliters divided by 1,000 gives us 0.5 liters. And then, so molarity is moles divided by liters, but we don't know the moles yet. So the first thing we need to do is convert grams of methyl alcohol to moles of methyl alcohol, and we use the molecular weight of methyl alcohol, which is 32 grams. Carbon is 12, each hydrogen is 1, and then the oxygen is 16. So 9.45 grams divided by 32 grams per mole gives us 0.295 moles. So now if we just plug in 0.295 moles divided by 0.5 liters, we get 0.590 moles per liter, or 0.590 molarity. Molar, 0.590 molar. All right, here's another example. Chlorine is often added to water to keep it clear of living organisms. How many grams of Cl2, chlorine, should be added to 5 liters of water if we want the solution to be 0.045 molar? In this case, we know the molarity and we know the volume, but what we don't know is how many moles of chlorine we want to add. Of course, once we find the number of moles, we can then convert that to grams. So, if we take the molarity, 0.045, multiply it by 5 liters, molarity is moles per liter, so the liters will cancel, and we'll end up with 0.225 moles of chlorine. So if we take 0.225 moles of chlorine and dissolve it in 5 liters of water, we'll get 0.045 molar. Of course, if we need to know the grams, then all we need to do is convert 2.225 moles of chlorine to grams by multiplying by the molecular weight of chlorine, which is 71 grams per mole. So we need 16 grams of chlorine. If we take 16 grams and we dissolve it in 5 liters, we will have a solution that is 0.045 molar solution. Okay, the other concentration unit that we're going to use is percent. So percent concentration. Percent concentration, and you probably already know what a percent is. A percent is the parts out of 100 parts of solution. The way that you can find the percent is to take the part divided by the total times 100%. Now, when we're talking about solutions, there are 3 different percent units that we can use. Okay, so the first one is a weight-to-weight percent, and this one's fairly straightforward. To find the weight-to-weight percent, we take the mass of the solute in grams divided by the mass of the solution in grams. Again, the part, the solute, divided by the whole, the solution, times 100% will give us the weight-to-weight percent. So for example, if we want to calculate the weight-to-weight percent of a solution prepared by dissolving 35 grams of table sugar into 300 grams of water, well, we need to take the mass of the solute, which is 35 grams, and divide it by the mass of the solution. Now be careful here because we're told that we have 300 grams of water. The water is the solvent. The solution is the water plus the sugar. So if we add those together, we get 335 grams of solution. So 35 grams divided by 335 grams gives us 10.4% solution. The second kind of percent that we can look at, which is probably one of the most common, is to look at weight per volume, especially if we're taking a solid dissolved in a liquid. So it is the concentration that expresses the number of grams of solute in 100 mils of solution. So in this case, the solute has to be in grams and the solution is in milliliters. Because it's grams and milliliters, we can't really separate the solute and the solution. So in this type of problem, you'll be given the volume of solution, or that'll be what you'll have to find. Okay, so grams of solute divided by milliliters of solution times 100%. Another way that we could use this equation, as you see on the right, is to take grams of solute divided by 100 mils. And so this equation you'll probably use more often if you're trying to find the grams of solute and you already know the percentage, because then you can say the percent equals so many grams per 100 mils. And I'll show you an example using both of these equations. Okay, so the first example, calculate the weight per volume percent of a solution made by dissolving 8.95 grams of sodium chloride in enough water to give us 50 milliliters of solution. Alright, so this one's pretty straightforward. We want the mass of the solute, which is the sodium chloride, 8.95 grams, divided by the volume, 50 milliliters, and then times 100% gives us 17.9%. Let me just make a note. Using that second equation, if we kind of turned it around, 17.9% means 17.9 grams in 100 mils. And so that should make sense to you that then if we had 50 mils, 8.95 grams in 50 mils is the same as 17.9 grams in 100 mils. So that's where that second equation comes in, per 100 mils. All right, now example 2. How many grams of sodium chloride must be added to make 220 mils of a solution if you want a 22.4% solution? All right, so this time, since we know the percentage, it's easier to use the second equation. So 22.4% means 22.4 grams in 100 mils. So now we could do it a couple of different ways, but 22.4 grams in 100 mils, you could either then multiply by the new volume that you want, which you see over in the right, Where that comes from is you can set up a proportion. 22.4 grams is in 100 mils, so how many grams is in 220 mils? 220 mils. So 22.4 divided by 100 and then multiplied by 220 gives us 49.3 grams of sodium chloride. Our third percent then is a volume per volume percent if you're mixing two liquids together. And this one's very similar to the mass to mass percent. So it is the volume of the solvent divided by the volume of the solution. And it's important in this one that since they're both volumes that you want them to be in the same units. So either they can both be in milliliters or they can both be in liters, but they need to be the same. All right, so let's look at this example. A solution is made by dissolving 250 milliliters of glycerin in enough water to make 1.5 liters of solution. What is the percent volume to volume of this solution? All right, so we know the solute, 250 mils of glycerin, and we know the solution, 1.5 liter of solution. We need to have them in the same unit, so you could go either way. You could convert the milliliters of glycerin to liters by dividing by 1,000, or you can convert the liters of solution to milliliters by multiplying by 1,000. So that's what I've done here. So now it's just the volume of the solvent, 250 milliliters, divided by the volume of the solution, 1,500 milliliters, times 100% gives us 16.7%. Okay, so let me just talk a little bit about the glassware that you can use in the laboratory. Unfortunately, this class doesn't have a laboratory attached to it, so you don't get very much experience, but you could probably imagine some of this from working in your kitchen. So you can see here a graduated cylinder is used to measure a variety of volumes. So there's different size graduated cylinders. I have some that are 10 milliliters all the way up to 2 liters. This one happens to be 500 milliliters. And you can see that you can use to graduate the name. You can measure any amount between 50 and 500 in this case. A volumetric flask there in the middle is a little bit more precise than a graduated cylinder, and you can only measure out a particular volume. So they come in amounts like 25 milliliters or 50 milliliters or 1,000 milliliters, something like that. So you have to make a nice round amount to use those. You can see on the right, if you look at the volumetric flask, what you'll see is that there's a calibration mark, and so what you do is you fill the volumetric flask up until that mark, and then you have exactly, in this case, 100 mils. A pipette is a third type of measuring device. It's sort of like a straw, so you can use a suction device to suck up the liquid into the pipette, and again you bring it up to the calibration mark, and then you've measured exactly 10 milliliters. In fact, it's like 10.00 milliliters, so it's very precise. Alright, so if we're trying to make a solution in the laboratory, just add one more little step to this. How do we do that? Well, we already have learned how to prepare a solution by weighing out a solid. That's what we just did. So you can find the quantity of the solute that you need to measure out, and then put it in one of the graduated cylinders or in a volumetric flask, and then fill with enough water to get the solution that you want. So let's look at this example. How can we prepare 500 milliliters of a 0.154 molar cobalt chloride solution? All right, so we saw an example of this just a few slides ago. To weigh it out, we need to know the grams, but before we can find the grams, we need to know the moles. And so if we take the molarity times the volume, make sure that the volume's in liters, 0.5 liters times 0.154 moles per liter, says that we need 0.077 moles of cobalt chloride. Well then, cobalt chloride has a molecular weight of 129.9 grams per mole, so 0.077 moles times 129.9 grams per mole gives us 10 grams. So what we need to do is weigh out 10 grams and then dilute it with water up to 500 milliliters. So here we can see the picture very clearly. We measure out the solute, in this case cobalt chloride, 10 grams. Then we put it into the bottle, into the volumetric flask, put some water in there, shake it up, stir it up. Usually there's a lid that fits on top of the flask. So you swirl it or you shake it until all the solute is dissolved, and then you add additional water or whatever solvent up to the mark, and then you have your solution of the correct concentration. Now, there's one other way that you can make a solution, and that is by diluting something that is more concentrated than what you're looking for. In this case, we're going to use the following equation. C1V1 equals C2V2. So C1 just means the concentration of the first solution. V1 is the volume of the first solution. C2 is the concentration of the other solution, and V2 is the volume of the other concentration, the second concentration. So let's look at an example. How would you prepare 250 milliliters of a 0.5 molar solution of HCl if you already have a 1.5 molar HCl solution? Now you might get a little bit worried and say, well, how do I know what's 1, what's 2? Well, the good news is that it doesn't matter as long as you get the correct ones to go on the same side of the equation. So a trick is to look for the word of, because usually you'll see, in this case, 250 mils of a 0.5 molar solution. That means that they go together. We'll call that solution 2 because that's the one we want to make. We want to make 250 mils of a 0.5 molar solution. So C2 will be 0.5 molar and V2 will be 250 milliliters. Now, the solution that we already have is 1.5 molar, so that would be the concentration of the first solution. And what we want to know is how much of the first solution, V1, do we need to measure out in order to get 250 milliliters of the more dilute solution. So we just plug it into the equation, C1V1 equals C2V2. Another trick to keep in mind is it doesn't matter if you use milliliters or liters in this case, as long as they're the same units. So, and the same thing with the concentrations. You can use percent concentration or molarity concentration as long as they're the same on both sides of the equation. So here I've kept it in milliliters, and so my answer will be in milliliters. So C1 is 1.5, V1 is what we're looking for, C2 is 0.5, and V2 is 250. So if we solve for V1, 0.5 times 250 gives us 125, then we divide both sides by 1.5, we get 83 milliliters. So what does that mean? We need to take 83 milliliters of the more concentrated solution, measure it out, then put it in a graduated cylinder that's 250 milliliters, that holds 250 milliliters, and then we dilute to the line with water. In this case, you could actually figure out how much water you need to add. 250 is our total, 83 is what we're starting with, and so 250 subtract 83 means that we have to add 167 milliliters of water. But usually if you're using a volumetric flask, it just means fill it up to the mark, and then you know you have 250. So here's an example of what it looks like to dilute a solution. So we have a stock solution, which is a particular concentration. We'll call that C1. And then we know how much of that solution we need, V1. In this case, they're using a pipette, which will be a very exact number, say 10 milliliters. In our last example, we needed 83 milliliters. That's a little hard to do in a pipette. So what we would have to do is pour some in a volumetric flask. I'm sorry, in a graduated cylinder, because 83 is sort of an odd number. But either way, you take out the amount that you want from the stock solution, pour it into the second volumetric flask, which in the last example was 250 milliliter flask. So you put the 83 milliliters in there, and then you just add water up to the mark. And so you've diluted the solution. Okay, C1V1 equals C2V2. All right, here's one more example for using our C1V1 equals C2V2 equation. A nurse wants to prepare a 1% weight per volume silver nitrate solution from 24 mils of a 3% solution. How much water should be added? So this time they're actually using the whole 24 milliliters of the 3% solution. All right, so again, we'll make solution 1 being the one that's already made, which is a 3% solution. So C1 equals 3%. And V1 is 24 milliliters, because that's how much we're going to use. What we're looking for is V2. We want to know what the total volume would be. Actually, first we have to figure out the total volume, and then we can figure out how much should be added from that. But C2 will be 1%, and V2 is what we're looking for. So C1 is 3% times V1, 24, equals C2, 1% times V2. If we solve that equation, we find out that V2 is 72 milliliters. So to have the same 24 milliliters of the 3% solution, and if we want to make it 1%, that means we need to have a total of 72 milliliters of V2. Well, if we start with 24 and now we want 72, we have to add 48 milliliters of water. Again, it doesn't matter which solution you number as 1 or 2, as long as you get the correct concentration and the correct volume on the same side. Look for the word "of" to link the two together. You might be interested in this link that I've put down here, the PHET Colorado. I think I've shown you some other ones earlier. This one, you can kind of play around with dilutions and concentrations. So if you want to take a look, you might want to stop and do that now or do it later. And that's the end of this slideshow. And I've got one more that will finish out the unit.